My name is Vladimir Michal. I am Decommissioning Team Leader in the IAEA Department of Nuclear Energy, and I will be very pleased to support this presentation. Kristina, over to you.
Thank you, and hello everyone. My name is Kristina Gillin. I'm a principal consultant with Vysus Group, and there I work primarily on nuclear waste and decommissioning out of Sweden.
Okay, so let's get started. First of all, I would like to highlight what is the International Atomic Energy Agency. The organization has been established in 1957. It has recently 172 member states, about 2,500 multidisciplinary professionals, and support staff from more than 100 countries. Actually, our headquarters is in Vienna. We also do have nuclear laboratories in Cybersdorf and marine protection laboratories in Monaco, and some local and safeguards offices in Geneva, Tokyo, Toronto, New York, and Rio de Janeiro. So really worldwide organization. Our slogan is Atoms for Peace and Development, and the agency shall seek to accelerate and enlarge the contribution of atomic energy to peace, health, and prosperity throughout the world. And our three main areas are safeguards and verification, safety and security, and science and technology. So I can consider myself being from Department of Nuclear Energy at the part of technology. Here you can see our headquarters in Vienna International Center. There is one screenshot from the IAEA General Conference, and also our work very much aligned with United Nations Sustainable Development Goals. Several of them are directly related to work of the IAEA. This webinar is proposed to highlight the IAEA considerations and perspectives on nuclear decommissioning, then to present technical aspects regarding activities and preparation and implementation of decommissioning, also to promote circular economy principles applied to nuclear decommissioning, and to present some good practices in support of sustainable decommissioning. Just to give you an example, this picture is photo from reactor hall of V1 NPP in Bohunice in Slovakia, and you can see there heart of any nuclear reactor facility. So it is a power reactor or pressure vessel that is retrieved from its working position and be ready for movement and fragmentation in some other places. So this is what is nuclear decommissioning about, basically. Nuclear facilities worldwide. First of all, overview of power reactors. There are recently about 50 power reactors in operation, in the construction, over 440 in operation, and about 190 were shut down for decommissioning, and about 20 were already decommissioned. Research reactors and critical assemblies, the picture is different. We have under construction 11, in operation 220. There are some shut down, and under decommissioning recently over 400 such research reactors. And in the bright pictures, you can see distribution of age of those reactors. So they are certainly aging. Nuclear facilities, again, a picture is a little bit different. Under construction, about 23. In operation, over 330. Some under temporarily shut down, and permanent shutdown and decommissioning about 150 versus 130. This aging distribution is, in this case, is slightly better. However, it certainly continues as well. Demand for nuclear decommissioning is growing in all countries. The first reason is aging and the end of operational lifetime as the most important thing. There are nuclear decommissioning entities or specialized companies established in many countries to implement safe decommissioning. They can be government-owned or private. Nuclear decommissioning industry market is also increasing both on national and international levels. So it is really business as usual. And more countries need to address decommissioning issues in mid to long-term perspective. What aspects, especially technical aspects, are important regarding decontamination, dismantling, and demolition? First of all, I would like to offer you definition of decommissioning. Don't worry, it will be only one definition in the presentation. It is from IAEA General Safety Requirements Part 6. The decommissioning is all administrative and technical actions taken to allow the removal of some or all of the regulatory controls from a facility, except for part of the disposal facilities that are not decommissioned but closed. So it is a typical safety-oriented definition. At the beginning of the decommissioning phase, usually spent fuel and operational waste are to be removed during so-called transition phase. I'll show some picture about this bit later. And typical main technical decommissioning activities are physical and radiological characterization to have enough data for follow-up planning and implementation of decommissioning, decontamination, dismantling in terms of cutting, fragmentation, disassembling, whatever, and demolition of large concrete structures. Decommissioning technologies are in fact available and well developed, but still some R&D is needed in some special cases. R&D in terms of remote handling tools, advanced robotics, maybe some simulations, visualizations. Of course, it is especially a case for facilities that are in difficult difficult status. For example, after an accident or what we are calling legacy facilities. A typical part of decommissioning is management of large amount of material and radioactive waste. Majority of waste are typically non-radioactive, but there can be also hazardous materials, for example, asbestos or beryllium or some others. Part of the work is also clearance of materials, so that will give opportunity to reuse materials in the future. Some remedial actions at the site might be necessary to achieve the final goal of decommissioning, and it is the release of the facility and site from the regulatory control. Here is the picture that indicates decreasing of radiological hazards in time during the decommissioning process. The first part of the picture is about operation, where the radiological hazard is more or less stable. Typical time for operation of nuclear facilities, let's say power reactor, is 30 to 50 years. For research reactors, they are even older facilities. There will come a permanent shutdown anyway. That's unavoidable fact. And after that will start what we are calling transition period from operation to decommissioning. That may be from 1 to 5 years or longer. During this period, is operational license still in place, but there can be done a lot of activities in preparation for further decommissioning. Fuel removal, for example, drainage of circuits, conditioning of operational waste, cleaning and decontamination, and certainly must be prepared documentation for the decommissioning license. Once the decommissioning license is issued, there is a time to implement decommissioning strategy. There are two basic options, two basic strategies, but this is theory and real life is more colorful. First option is immediate dismantling. It means that decommissioning continues without any unnecessary delay towards the release of the end state. Second option is preparation for safe enclosure. There are different terminologies. I'll introduce it a little bit later in different countries. The safe enclosure can be in place for several decades. Here is indicated up to 50 years, what is certainly reality. And after that is done final decommissioning. Brief overview of the IAEA activities on nuclear decommissioning. So I already provided definition from the general safety requirements, what is a part of IAEA safety standards. So we do development of safety standards and also technical reports in support of planning and implementation. We are organizing expert missions and peer reviews of the national programs, a variety of training courses and workshops, scientific visits and fellowships that are organized for our fellows from various countries, and conferences and technical meetings. We do have several so-called collaborative projects on, for example, on global status of decommissioning, on human resources development for decommissioning, on completion for decommissioning, etc. Several years ago, we established international decommissioning network that comprises all decommissioning-related activities. We developed e-learning modules on decommissioning that are available for free to our participating member states. We do have databases that includes details on those aspects. We developed the decommissioning or nuclear wiki with a set of case studies and technical descriptions. We do have several collaborating centers on decommissioning with recently 4 organizations in 4 member states, but more are coming in the near future. Kristina, over to you.
Thank you, Vladimir. So a few words about circular economy principles in the context of nuclear decommissioning. And one thing there to keep in mind is like the rest of the world, the nuclear industry certainly is embracing the circular economy and sustainability thinking both. But it's important to keep in mind that the vast majority of the reactors were built long before these concepts were even invented, and even more since kind of they became mainstream. So the figure on the screen at this time is similar to what Vladimir was showing earlier, but in a little bit of a different numbers on the axis, just showing that the vast majority of reactors were built then really before the 1990s. We have a slow and steady growth since, and it's certainly picking up. But all those early reactors were built without keeping even decommissioning in mind to the degree that is expected today. So new reactors, of course, have much more potential in implementing circularity as part of its whole life cycle. But having said that, the nuclear industry has also been very good at implementing some practices, in fact, very early, that are in line with circularity to reduce and minimize the amount of waste in general. I'll come back to that. Several countries are reprocessing the spent fuel. France, the UK have had large programs, even Sweden initially planned to reprocess. That means really recycling the uranium and plutonium that's in the spent fuel. Also a large degree, a relatively large degree of thinking of reusing equipment and buildings, especially that is radioactive or contaminated or potentially contaminated, so that it doesn't become waste, because radioactive waste is very expensive to manage. So there's been certainly a driver to keep the volumes down. But I would also say that the application of circularity principles certainly is increasing, because again, that's where the rest of the world is heading, and our industry is no different than that. So when it comes then to the waste, we have, I would say, been very good from very early on to apply the waste hierarchy. Now, of course, that's debatable if that's truly circularity or not, but it certainly has been a way to reduce the volumes of waste that needs to be disposed of in a repository or a facility for permanent management of the radioactive waste, whether it's spent fuel, where you normally would plan to have that hundreds of meters down in the ground in a country, or the more what we call low level waste or intermediate level waste that maybe is more okay to have on the surface in a repository. And ways then that we have adopted very early on is avoiding. Just to give an example, where the good practices is you do not bring in anything into the radioactive areas or the potentially radioactive areas that you don't have to. So you would remove your components from the cardboard boxes and then don't even bring in the cardboard boxes, because if they've been on the radiological side, they would become waste or potentially become waste. Minimization to compact waste, to incinerate waste that can be incinerated, reusing and recycling, of course, after you then remove the radiological contaminants, and then you could recycle metals and so on into the normal stream of metals. But you will remain, regardless of you apply it, a certain volume of waste that needs to be disposed of in dedicated facilities for permanent management of spent fuel and other radioactive waste. Some other thoughts then, if we take a kind of step back look at circular economy principles in the context of nuclear decommissioning. I think it's important to keep in mind that the prerequisites really vary very much between countries and over time. And part of this is that they're vastly different regulatory requirements. For example, some countries you may not be even allowed then through the regulations to remove waste or material that has been on this radiological side, free release it and treat it as conventional waste. Whereas others, or the majority, I would say, have certainly those possibilities and are even encouraged. There's also, of course, differences in emphasis of circularity by owners and operators. And as I mentioned before, we're certainly seeing an increase in the interest, both on the operator side and also on the international side, like the IAEA is also now having initiatives on circularity for the nuclear industry to a much larger degree than previously. And last but not least, the public acceptance and whether they are interested in or emphasizing circularity in the context of nuclear certainly will have a large impact on the degree that you can actually implement it. We are operating in an industry where we are highly dependent on both the political but also the public view and acceptance of what we do, not only in terms of building and operating new reactors, but equally when it comes to decommissioning and managing the waste. And this also tends to vary over time. Just before I move on to the next slide as well, I'll mention that the picture you're seeing here is from the southern parts of Sweden, a site, Barsebäck, with 2 units that have been shut down and basically sitting there. So to Vladimir's point before, where the intent was to decommission these as early as possible, not wait, but in practice, that doesn't mean that's going to happen. So they now are undergoing decommissioning and are being demolished. But when we say fast, it can still be decades. And I think it's also a good example of maybe that's a little bit unique to our industry, that circularity can mean not necessarily that you take everything apart and recycle or reuse the components once decommissioned, but because of these long timelines, you can also have uses on a site while it's awaiting decommissioning. And Barsebäck is a very good example of this, where they used, because Sweden has or had 12 in total operating reactors, and these 2 units that were shut down the first for political reasons, they were used by the other 10 as a facility for training their staff, because it was, it's pretty unique to have 2 full-scale reactors that they could do training on. So in that sense, there's some circularity, or just leveraging the facility, even if it's not to produce power, which was the original intent, but that you can have a valuable use also while it's sitting idle and awaiting decommissioning. Next, some words about then if we broaden the thinking and not just thinking circularity of whether it's the site and the buildings or equipment, or down to the materials that are eventually demolished, but of course sustainability then in a bit larger context. So one thing we're of course working on is, like all aspects, or like all industries, trying to minimize the environmental, social, and economic impacts, whether that's reducing power consumption or water consumption or what have you. But all those things are, of course, one way that the decommissioning industry can contribute to the larger sustainability aims or goals of society. What I would emphasize, I think is very important, if one has a goal to decommissioning a nuclear facility in a sustainable way, is that we really have to think of the local context, whereas circularity maybe is the same for all facilities wherever they're located. But if to really be sustainable, I think it's very important to think that each site is different. How you decommission in the most sustainable manner will depend on where it is located. Do you have a lot of people surrounding it? So meaning, for example, will jobs be the jobs that will be lost, or the jobs that will be generated during decommissioning? How much does that, do you take those aspects into account when you're planning your decommissioning? The degree to which you can reuse a site or a building will also depend very much on your local context. Do you have a site that's highly contaminated? That will probably limit what you can do after decommissioning. Or do you have a site that can basically become a green field and you can do anything on it? Thirdly, what I would advocate is if you want to build decommissioning on sustainability principles, and this is a little bit of a maybe development in the thinking, because the nuclear industry traditionally would basically to the point of the definition before you kind of plan to decommission and then you make the site available for other uses. But if you want to think really long-term, what I'm promoting is anyway that you really think beyond decommissioning and think, what are you going to use the site for after it's been decommissioned? And then you plan your decommissioning accordingly, because that will tell you whether you can reuse a lot of buildings, for example. Fourthly, one aspect that's important is to utilize local supplier. Again, this will be different depending on your local context, but this can be a great way to minimize the negative economic impacts on a local community if you at least utilize local suppliers to the extent possible. And lastly, for all of this and all aspects, it's very important in our industry and to involve public and local stakeholders so that they are aware of what's going on and that they support what's going on, because otherwise, and these might be very surprising. There's some examples here in Sweden where we had a smaller facility, a research or demonstration facility, also sitting idle for decades. And then when they were going to decommission it, actually some voices were raised and said, no, don't keep it for industrial, basically industrial architecture values, and so that they wanted to make it more of a museum. So you can have quite surprising support from your public and local stakeholders, one way or the other. The last slide I will present is just an example of, like I said, the kind of repurposing and circularity in general in the industry is a developing field, and in my opinion, this certainly will increase, because if we as a society in general are advocating reusing both large scale and small scale items, I mean, we built these nuclear facilities to last. They're very, very well built, and it's really is unfortunate to take them all apart unless there is a good reason to. And there are examples. One on the left of the screen there is the first research reactor, another example from Sweden that was for research, and they took all the radioactive parts out, and then when they had done that, it sat. They didn't know what to do, so it sat empty for like 15 years, and then someone had a great idea to use it for concerts or for like here it's for a presentation or training or research or what have you. So it's now a venue that's being used for all sorts of things, just to show the potential. This is small, but I think these early examples can also show the way for what can be done in the for larger facilities. And the other example is from Greifswald, Germany. This was a very large nuclear power plant site. Was planned to be for 8 reactors. They started 5. The 6th one was under construction. Then it was shut down at the end of the 80s. And now it is being decommissioned. But the whole site they're using, and to my point about a local context, it was very important really to have the continue to be an engine in the local economy and provide jobs and so on. So they have repurposed even very large, like the example here on this photo, a turbine hall where they are using it to assemble cranes, large cranes for conventional uses. So just to show that there is potential in this building if one really thinks long-term and circularity. I will end there and give the word back to you, Vladimir.
Thank you so much, Kristina. So let me show you a couple of more examples. We will now have more pictures than just the text. Well, first example is on reduction of facility footprint, because especially nuclear power plants and maybe fuel cycle facilities, they do really need large areas. This is the example of demolition of 4 cooling towers that belongs to V1 NPP in Bohunice. The other 4 nuclear powers belongs to other nuclear power plant that is in operation, so they really need to be there. But 4 cooling powers were fully demolished with the using of traditional conventional demolition methods, and the place is now ready to be free released or used for some other purposes. Another example is on release of the site for what it is the IAEA terminology, restricted or unrestricted use. First example is the greenfield after the decommissioning of NPP Niederreichbach. It was an NPP located in Bavaria in Germany. And greenfield, this is not the IAEA terminology, but it is easy to remember and often used. It is exactly unrestricted use. So if you will travel there, you can see only some memory stone with the information that here was in the past nuclear power plant, fully decommissioned, and the site can be used for anything else. The other example is a place that belongs to CEA, Commissariat Energie Atomique in Grenoble. There were 3 large research reactors historically those were fully decommissioned, fully demolished. The site has been cleaned, and the site still belongs to CEA, but it is now used for Energy and Material Research Center. So the same site that was used for nuclear purposes is now used for non-nuclear purposes, and it is something what we call restricted use, because some industrial use of the site is still there. Another example is the complete removal of the facility, but in addition, there is adjacent storage place for the spent fuel. It is the typical case for nuclear power plants in United States because of still pending solution for disposal of spent fuel. So here you can see example of Manienki site that was decommissioned. The plant was decommissioned, but there is still a small place like interim spent fuel storage place for the spent fuel in storage casks. And here you can see it is an interesting example. Even explosion is used in nuclear industry. This is the example of Manienki concrete containment, but we have also examples of chimneys in Sellafield and some other things. Deferred dismantling strategy, I mentioned it already. Here are two examples, one from Spain, it is nuclear power plant Vandellos 1, and one from UK, Bradwell NPP. I mentioned that there are several terminologies for this. Safe and closure is the IAEA terminology. Safe store is a short American technology. Care and maintenance, it is a UK terminology. Basically, it means the same. Means that the plant is placed into the safe enclosure for several decades, and this is the typical decommissioning or dismantling strategy for graphite reactors, because there is a large amount of graphites, hundreds, thousands of tons, and there is recently no sustainable and suitable waste stream solution for the graphite. So it is waiting for such solution in coming decades. And I also decided to include here one example of research reactor, not to create the feeling that the decommissioning is only about the nuclear power plants. It is about research reactors, fuel cycle facilities, and also thousands and thousands smaller industrial research and other nuclear facilities. So this is the example of research reactor Astra that was placed in Austria, in Seibersdorf. It has been gradually decommissioned towards the ground floor, and actually the dome of the reactor still exists. It is now used as a storage for the radioactive waste. One slide about the learning from other industries. I think that nuclear decommissioning can learn a lot from conventional demolition industry and vice versa. Conventional demolition approaches are used in a standard way in nuclear decommissioning. For example, what I mentioned for cooling towers as a huge constructions. Containment for the reactors might be another one example, and this is very special hard construction from reinforced concrete that is there to protect, for example, from the aircraft crash or some other, very difficult situation. So it is really very complicated to be dismantled, but it must be done. Then industries dealing with hazardous materials, for example, asbestos, beryllium, or some other materials that are hazardous nature, but because they were used in nuclear facilities, they, in addition to this, might be also contaminated. Another industry that is interesting for us is oil and gas platforms decommissioning, especially for the management of large components and retrieval and transport of the large pieces of components. So we also do have established some cooperation with this industry in this area. And last but not least, visualization and digitalization that are applied in conventional industries. In nuclear industry is done a lot of visualization, digitalization, but there are some more advanced examples from other industries. Actually, this first point, conventional demolition industry, that's why we established very good cooperation some years ago with the European Demolition Association. They are invited for our meetings. We can support meetings of EDA. I would be very pleased to organize more, but COVID-19 restriction time is a little bit difficult in this regard, but it will improve. And actually, it concludes our presentation.